So in order to use the lathe to fix the lathe, I had to rig up some way to move the carriage. And what I came up with was a piece of threaded rod that bolted, one end bolted to the carriage, and then the other end had a nut welded onto that piece of flat bar bolted to the carriage stop. And then I welded a nut on the end of the threaded rod, jammed the two nuts on the other side of that piece of angle iron, and with the drill I'm sort of able to drive it. In editing the video, I noticed that piece of angle iron bolted to the carriage kind of flexes, and that's where I was kind of getting some jumping of the carriage as it fed. It wasn't super smooth, but it's good enough to get things done. Here I've got the worm for the longitudinal feed that was galled in the bearing, chucked up, and started the first cut without tightening the quick change tool post, which makes for a terrible surface finish when that tool holder's just bouncing around on there. There's a large tapered washer that sits up against the worm that is takes the thrust against the cast housing, and so I had to leave the diameter up near the threaded, the gear part of the worm in order to for that conical washer to sit on there properly. So. Turned it down to about 1,000th oversize, and then filed and sanded it down to size. I wanted to get a good finish on it, as it is a bearing surface running inside the bronze bushing. After sanding, I hit it with some red Scotch-Brite and then finished off with the gray fine Scotch-Brite. It gives a nice finish to steel. I really liking that gray Scotch-Brite. And here's the worm with that conical washer that thrusts up against the cast housing. To make the bushing that's going to get pressed into the apron housing, I grabbed a piece of bearing bronze, I believe it was 932, and began turning the OD down. As you can hear from the sound, the
getting a smooth feed with the drill rig is a little bit tough again. I think it's related to the flexing of the piece of angle iron on the carriage. Really should have beefed that up a little bit.
So, dangers of working too late at night. What was the second to last cut on this, I was going to take 80 thousandths off the diameter, and in classic rookie mistake, took 80 thousandths off the radius, which put it about 40 thousandths undersize. So, fortunately, I had a second piece. We'll start over again. You can see the surface finish isn't very good. I'm going to try changing tools, but my drill feed mechanism I'm working right now is kind of not very smooth, so I think that's not helping the surface finish. But anyway, had a good sleep on it, and guess we'll start over now.
After getting the OD to the correct diameter this time, I went ahead and bored the ID to fit the diameter that I'd turn the worm down to previously. Got a nice fit with that worm in the bushing. In order to protect the finish on the OD, while I part that off and face it to length, I'm using some little leather jaw protectors I found with aluminum and brass. It's hard to protect the finish with aluminum or brass jaw protectors, so I've got some 1/4 inch thick pieces of leather that seem to do a real good job of protecting the finish. The other thing I found with the leather space, obviously you can't take heavy cuts, and you've got to be careful of how crazy you're getting with the part. But I've also found that I can knock the part around in my 3-jaw chuck a little bit, and usually get it running within less than a thousandths of run out, which is pretty good for an old 3-jaw chuck like I've got. Again, like I said, you've got to be kind of careful of the depth of cut and how crazy you get. One real problem I had with the threaded rod setup was the fine adjust. As you can see, I'm putting some tension on the rod and then tapping the end of the carriage with a lead hammer. I've got a dial indicator stuck to the ways of the lathe to try and just see how get it to the dimension I need, but to get it there I had to bump it around with the lead hammer. So after getting the bushing parted off and face to length, went ahead and took it out. Here you can see the little leather jaw protectors I use, and pretty nice surface finish on the part. And it's got a good sliding fit with the worm. Probably could have made it a little bit tighter, but sure a lot tighter than the worn worm in the worn casting. In order to get the bushing pressed into the cast housing, I put the heat gun on the casting for about 20 minutes, set it 1,000 degrees. Yeah, as close as one of those heat guns is to what it says it is, but I stuck the bushing in the snow outside the shop while the part was heating up. And after I figured out how the Loctite cap worked, I used a little bit of Loctite 609. It's the bearing retaining compound on the bushing to get it, make sure it doesn't move around over time. I've got a Morse Taper 4 adapter in the spindle, the horizontal spindle of the mill, and had that there just in case it needed a little bit of press to push the bushing in, but it slid in just fine with the casting heated up. And so I just ran the table in to kind of use that Morse Taper adapter to hold it in place while the Loctite set up. After giving it a few minutes to sit, just checking the temperature, I kept the bushing about 10 thousandths shorter than the length of the casting so that the thrust washer on the worm would still ride on the original surface there on the casting. To mount the part on the table, I had a couple half-inch thick parallels under the machined surfaces on the back of the apron housing where the shafts that retain the longitudinal and the cross feed clutch assemblies go. I don't think I ever got that in the video, but that was the reference surface that I was mounting them on, hoping that it was in line with the bores for those worms. It did appear to be. Now came the moment that I was pretty nervous for the whole time, was to check the alignment of that board housing to make sure that it was still in line with the other original bore. There's a keyway on the lead screw that drives those worms that you have to get lined up to get them on, but everything went on and appeared to be working and fitting. That was a pretty happy moment when everything was lined up. I had to drill from the oil reservoir through the bushing down into the bore so that the oil could feed down in from its little reservoir there. On the original housing, there's a groove that runs from the hole along the top of the bore to feed oil along the whole length of the worm. As you can see, got that groove that's cut, so I need to add that into the bronze bushing. So I put a carbide burr in the Dremel tool and tried to hack a semblance of a groove in. It wasn't entirely pretty, but should work to get the job done and get the oil distributed along the top of the worm. After cutting in the groove with the carbide burr and the Dremel, I just took a triangular file and cleaned up the groove so that the get rid of the burr that was left by the carbide. With the bushing in and ready, it was time to try and assemble everything and getting the worms in and the locking collar or the collars on. They're left-handed thread, but it says left hand on them. You'd think it'd be easier to get them on, but there's a set screw that locks them in place once you get them adjusted. It's got a little brass plug at the end of the set screw to protect the threads. Apparently the recommended backlash or play in these is between 2 and 4 thousandths. So I was using a 3 thousandths feeler gauge to set that the amount of play in those worms. There's that little brass plug that protects the threads from the set screw. Actually, when I took them apart, I was taking them apart in a tub of mineral spirits, and I lost both the brass plugs. So I just made some new ones and put them in there to lock those collars down.
Okay, so the problem I've got now is that when this collar's tightened down all the way, there's 1.892 inches, and here with the wear on these thrust surfaces, I'm at 1.871. So there's no way to tighten this up enough to get the 3 thousandths I'm supposed to have here. So what I'm going to do, since this part is much easier to recreate if necessary than this part, I'm going to relieve the thread here about 100 thousandths. Well, maybe 50. So that I can then get that tightened up like it needs to be.
So in order to relieve the threads, I chuck the part up and bored out cut out the threads a little bit. As you can see, I'm using my high-tech wrench method to advance the carriage towards the chuck. As Not nearly as smooth as it's supposed to be, but did work. And actually the setting the play in those worms was a kind of a test run, because in order to get the apron back together and get the worms over the worm gears, I needed to take them back off it. As you can see here, here's the eccentric on the inside of the worm gear that drives the oil pump. The oil pump fits up through the bottom of the apron, and if I can get the camera back where it belongs, runs on the eccentric. This is the clever way that the crossfeed clutch is retained on the shaft. There's a split washer with a groove around it, and then a spring clip that goes around it, and that way the parts are assembled on the shaft, and that's snapped in around them and locks everything in place. Now the battle to get the back half of the apron on begins. Took several tries to figure out what needed to be in place and what needed to be added, but I'm taking the worms out. I couldn't get the worms wouldn't fit over the worm gears, and so those have to be removed and installed afterwards, and then I had to reset the play in the worms themselves. I put a little bit of the non-hardening sealer between the front and back halves. According to James McDermott, in the factory they were just scraped surfaces that were fit up tight with a little film of oil, and that was enough to seal them. There's no pressure on it, just the weight of a couple inches of oil, but I figured a thin layer of the non-hardening sealer wouldn't hurt anything and might do it some good. Here I'm just trying to get the play in the worm gears set again with the two halves of the apron back together, and go ahead and put the oil pump back up in.
This guard goes on that. It's got two screws go in these countersunk holes, so I'm guessing it's an original part. It doesn't quite look as I don't know. I'm not sure if it's original or not. Nice big zinc crystals on there from the galvanizing, but boy, it's a ratty piece. I wonder if somebody... Well, it's got the 4 stamped in it. Everything on this apron has a 4 stamped in it, so maybe it is from the factory. Just not quite the quality of everything else. Another problem, I'm wondering if some of the problems with this, getting the debris and stuff in here that caused some of the problem with this worm, is this opening here is towards the headstock. So I think I'm going to try and cover that up with the Got some weather stripping, just foam weather stripping. I'm just going to put it in that gap, and shouldn't hurt anything, and I'll bring it around, and then it'll get pinned in by the cover.
Now it's time to try and get it all back on, getting the keys and the worms aligned with the groove in the lead screw, and everything lined up the way it needed to be. Took a bit. Actually, to be honest, I cut a lot of video out here. It took me a lot longer than I'd like to admit to get that on, and then get the carriage over it, and get them bolted together, and had to do a lot of fiddling. This is the bracket that holds the clutch lever that runs on the apron. It also is the same lever that kicks out the feeds if you there's some stops. And I didn't realize it, but those knurled rings down by the handle are actually adjustable, so that's how you get the fine adjustment in the stops. If anybody has one of these lathes, I wondered how you could get a very fine adjustment. And, James McDermott told me that's what those are for. And then once I cleaned them up, they actually work now. Can't see it very well, but there's a scissor jack down underneath the apron holding it up. I'm just putting some straps around the handles on the apron to hold the apron up against the bed, so I can unbolt the bracket and get the carriage ready to slide over. This is just a little bracket I made to help throughout the pulling it off and putting it back on. I just cut a couple slots in, put the screws that hold the apron to the carriage can hold in. I just did that, so there's some adjustment side to side. Put a couple holes in it, so I had some room to hook it up differently to get it to hang straight. And put a little oil in the galley, the reservoir up on top, just so it was full when I started it up again. As you can see, I took some time to clean and polish the hardware on the front of the apron. Sure makes the rest of the lathe look sad, but it was easier to do it then than later. Here I'm just raising this scissor jack up actually I had to lower it a little bit to get the gear that runs the cross feed on the carriage to fit over it. I could just raise the apron back up to the bottom of the carriage with the scissor jack. I'm just trying to make sure the holes in the carriage are aligned with the ones in the apron. I'd forgotten to clean the bottom, so I slid it back off to clean the bottom. See the flaking from this. They're the scraping, I guess it would be. These are the scraping marks from this was scraped in at the factory. I tried to talk during this part, but with the once I turned the lathe on, I couldn't hear anything. I just thought I'd run it through its paces. The lower lever at the center of the apron is the clutch lever. Engages the clutch for the main drive, starts the spindle going. There's another handle hidden there around the corner, one that stays fixed there near the front of the headstock, and then the other one travels with the apron. So if you're down, this isn't a very long bed. Some of the, you can get these with quite long beds, but put in a little higher spindle speed there. See if it'll go. I did replace the key that slides in that apron thing. Here's the you can gauge the, if you notice the lead screw is not turning until the lever on the right of the apron's engaged. Now it's turning forward, and so you can engage the longitudinal feed or the cross feed. And then when you pull the lever up, it reverses the lead screw. Now the lead screw is turning in reverse, and then the cross feed's turning in the opposite direction. And that also reverses the longitudinal feed. And you can turn them both on and cut a 45-degree taper. Actually use that quite a bit. And the half nuts now engage properly, like they weren't doing. Started the whole effort. Engage, push the lever down, and the lead screw starts feeding towards the headstock. Pull up on it, it reverses. When you're cutting threads, typically the half nuts are engaged and just left engaged, and the forward and reversing is done by reversing the lead screw itself. On a longer thread, I guess it might be handy to disengage the half nuts and run the carriage back. The threading dials were an option with the Hendey lathes because I guess it was just assumed you were going to thread using the reversing lead screw. There's a lockout so that when the longitudinal feed's engaged, the half nuts can't be engaged. But it doesn't work with the cross feed, which would make some interesting threading to have the cross feed going with the half nuts, but I guess it won't tear itself apart like it would with the longitudinal feed. When the lead screw's turning, it runs the eccentric on that worm, which pumps oil up into the carriage and into the cross slide, and oils all of that is fed through the oil that's in the reservoir in the apron. There's some orifices that you can adjust the height of them, and that adjusts how much oil flows through that system. I don't remember what I was saying now, but I'm sure it was terribly important. Oh, when over about 200 RPMs, you're not supposed to reverse the lead screw because of the slamming that occurs on that single dog or single tooth clutch. So if you do need to run the lead screw at those higher RPMs, just disengage the clutch, engage the lead screw, and then ease the clutch in, and it works well. Overall, I'm pretty happy with it. It makes the rest of the lathe look not quite as nice. I did do the tailstock while I had it off, but overall, I'm sure happy to have things back running the way they're supposed to. Thanks for watching, and hope you enjoyed it.